So let's look at the conformations of a simple molecule. And when it comes to simple and carbon-carbon single bond rotation, you don't get any better than ethane, revealed there in its full glory. Actually, of course, that's not even close to its full glory, because we need to think about it in 3 dimensions. And so here is the model of ethane I'm going to use for this particular movie here. So first of all, it's a 3-dimensional model. If you look at the picture, you've got 2 hydrogen atoms on each carbon are resting on the table. So obviously they are at the bottom of the molecule. They're going back as we're looking at it here. And the way I depict that is with these little hashed lines here. So there's the 2 hydrogens there and there. There's the 2 hydrogens there and there. Now then I've got a carbon-carbon single bond that, because I've drawn it as just a regular old line, that's implying that it's in the plane of the paper or the plane of the screen, as the case may be. And then these wedges here are saying coming towards you. So there you can see this hydrogen here matches that one there. This hydrogen here matches that one there. Coming towards you, indicated by those solid wedges. Now what I want to do in order to think about the conformations of ethane is I want to rotate around this carbon-carbon bond. I'm actually only going to have to rotate by 60 degrees because, as you'll see in a minute, that gives me both of the possible important conformations. Now while I could think about that, drawing it in a way like this one, and the last thing I'll show in this movie will be the other conformation drawn in this way, I could have a better feel for it if I just think about the model from this perspective. But really the best way that I can think about the conformations as I rotate around the carbon-carbon bond is to actually look down the bond. And so here we've got a movie in which I'm going to attempt to do just that. So we're starting off with the same view that we've got here. Okay, the carbon-carbon bond there, carbon-carbon bond there, silver coming out at you, green coming out at you. By the way, I've color-coded the carbons and hydrogens just to make it also a little bit easier to see. So this carbon here, which will end up being the back carbon, because I'm going to look down the bond in this way, the hydrogens are silver, the bonds are grey, and then what will be the top or the front carbon, you've got the bonds are purple and the hydrogen atoms are green. So I'm going to start the movie, and I have to be careful here because if I click in the wrong way, I'll bring up pictures instead of movies and vice versa. And I've spent so many attempts to get this right that if I screw it up, I just screw it up and we'll keep going. Anyway, starting the movie, as my finger's saying, I'm going to look down this bond. So what I'm going to do is I'm going to pick up the molecule and turn it around a little bit. There we are. So now I'm looking down, let me get a picture of that up here, I'm looking down the carbon-carbon bond. So this carbon here that had the purple bonds and the green hydrogen atoms is now in front, and the carbon behind is the one that you can hardly see. You can see it poking out there behind in this picture. You can hardly see it at all there. It's this carbon. It is completely eclipsed by the front one, and indeed that is the name used for this particular conformation. Okay, so the back carbon there, you can just about see one of its silver hydrogens, you can see vaguely that grey bond there behind, and so on. So an eclipsed conformation in which the front carbon completely sits in front of the back carbon in terms not just of the carbon atom, but also in terms of the bonds to that carbon atom. Now, it's very, very tough to see that from a picture like this. So what we do is we use so-called Newman projections. Now, Newman projections are just this view exactly here depicted. So the green ball there is the carbon atom. See this front carbon atom, you see all its bonds, as you can on the Newman projection. This little Mercedes-Benz representation there. Purple bond going up to hydrogen, purple bond to hydrogen, and so on. Now, of course, you can't see the back carbon, where you don't need to see the back carbon on the Newman projection. But what the Newman projection does is it doesn't show you the carbon, but it shows you the bonds sticking out a little bit. Now, in this particular case, for the eclipsed one, you can't actually see the back bonds and the back atoms. And there's 2 ways to show that. You can have this way here, which is, I believe, the older way of showing it, so that this hydrogen here is actually the hydrogen tucked away behind the green, but you offset it a little bit just to show that it's there. The other way to do it, which I prefer, is you just say, well, this green hydrogen right there is right in the way of the silver or the black hydrogen behind it, so we just put that hydrogen in brackets. So hydrogen, then hydrogen in brackets for that one. Green hydrogen here, you can just see the silver one there, but put it in brackets. And then same on the left, green hydrogen atom with the one behind, just in brackets. So an eclipse conformation in which when you look down the carbon-carbon bond, the atoms on the back carbon are being eclipsed by the atoms on the front carbon. Now let's see if I can get the video going again. Going to pause and play. There's my hand coming in, because now what I'm going to do is rotate. So rotating, 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 and leaving it there. Now what I've done is I've rotated by 60 degrees to get this picture. So the same view for the front carbon, there is that same Mercedes-Benz configuration. In fact, let me draw it out there. There's the Mercedes-Benz arrangement there for the front carbon. But now for the back carbon, it's no longer eclipsed by the front carbon. In fact, it's exactly halfway between being eclipsed. If I'd continued rotating, then this silver ball would end up behind that, this silver ball behind that one, and that silver ball behind that one. But here we are halfway between two eclipses, and this is what's called a staggered conformation. Okay, staggered conformation, you can see it really well thinking about this projection or the Newman projection, because you've got the front, the back, the front, the back, the front, the back in a staggered arrangement. Okay, so two possible conformations for ethane, and of course you can have all the ones in between, but the sort of ends of the spectrum you can have fully eclipsed, which is how I've drawn here, how I've shown here, and how we've shown in the Newman projection, in which the atoms bonded to the front carbon completely eclipse the atoms bonded to the back carbon. Or you can have this arrangement here, the staggered, in which it sort of goes front, back, front, back, front, back. Here is the side views of the model. You can see I haven't touched the front, the purple one, so I've still got two at the back, one coming at you, one coming at you. But now on the left-hand carbon, which was the back carbon, now I've got just one on the bottom, that's that one, and then two coming out at you, that's ultimately those two there. Okay, and then the way to draw that finally with little wedges, you can see front carbon again, two going back, one coming at you, back carbon, one going away, two coming out at you, those two there. Conformations of ethane. Hope it made sense with my little movie and everything.